Nope. The last one. Can you believe it? Okay, our boards are back from PCBWay. This is for the WSPRPI. And I was starting to think that I didn't have any 220 ohm 1206 resistors, but found them there at the end. Then these should be our SMA connectors. Yep. Everything is, 6 bags deep. Then I've got a couple of sets of pin headers. Those are for the Pi. Alright. See what we got here. There's our boards, our stickers, and another pen for my collection of PCBWay pens. They are getting to be quite the collection. Alright, let's get these out of here. Have a look. Maybe. There we go. Yeah. There we have it. Looks pretty good. Pad size is correct. Come on. Pin spacing is correct. Time to put them together. Let's get started. Now, this is my way of soldering SMD components. And I make no claims that this is the best way to do it. I am old enough that most of my career was spent doing through-hole work, and that is what I am comfortable with. But I can do some SMD work when necessary. I just don't like to. So we're going to start off by tinning one of each of those pads. Then I'm going to get some resistors out here. Okay. So I got some resistors out. I'm going to attempt to pick them up with some pliers. Pliers. Good God, Paul. These are not pliers. These are tweezers. What I like to do is just get one side tacked down. And once I get the one side tacked down, then we'll do the other side, making sure it doesn't tombstone. And then come back, make sure our first side is good. Oh, you get to see that. There we go. We zoom in further. That's about as tight as I can get, but there's our first resistor in. Now let's grab the second one. Not bad. Get that soldered in. Then I come back. I want to hit this other side again. Make sure we got plenty of solder. And this one does seem to be sticking up a little bit. So what I want to do is to kind of help it along. There we go. Not bad. Third and final resistor. sure you're working with a clean tip. What you can do is kind of pre-melt that and then slide that in there. And that'll help to keep it down there a little bit. And that should be, there we go, all of our resistors in. Now we do the same thing for the capacitors. A little bit of flux on the board helps to keep the solder where it should be. We don't want our solder flowing anywhere other than where it should be. All right, now we'll get our capacitors out. And yes, I do always shake out more than I need, because I have come to find that I do tend to send one or two of them flying across the room. Oop, that one moved on me. This time I'll just tack all three into position before I solder them all in, just to show you that there is more than one way to do things. You hear it clicking. That is the capacitor, or whatever component you're doing, putting itself firmly onto the PC board, which is, you know, exactly what we want. And I like these springy tweezers to do this, because if the piece is not fully down, then when you try and pull your tweezers away, you're definitely going to pull the component off the board. Which sounds like a terrible thing, but it's actually a good thing, because you'll know without a doubt whether or not you're soldered. And yeah, I'm probably using too much solder. How about a focus? There we go. Yeah, it ain't pretty, but it'll work. Okay, so next we'll put in our SMA connector. There's one right here. Now, the center pin is your signal, and all the others are ground. So, you know, realistically, you can put this into any position that you want. I think I'm going to go off the side of the board like that. Yes, I know, that's crooked. Whoops, and it's out of focus. Focus, there we go. At this point, I don't really care that it's crooked. All I want to do is get one leg soldered in. These are big and these are heavy. So, ooh. It's going to take a lot more heat than you normally use. That's not bad. See, you can see how crooked it is, but we're going to fix that right now by putting that down there, heating that up again, and getting everything in place. See? Now we're good. Now we can now we can solder the rest of the story. You might want to turn your soldering iron up a bit when you're soldering these joints. Again, because, you know, this is heavy brass, and it is going to soak up some heat. So you definitely want an iron that has a good thermal mass to do this. It's no harder than soldering anything else. Just takes a bit more heat and a bit more time. So there's all our grounds. Now we'll get that center pin on there. You want to focus for me? There we go. Not bad. So all we need now are our pins, right? Header in a board. Just like that. And if I calculated everything correctly, it should fit in perfectly. And once again, what we're going to do is we are going to solder one pin just to get it to hold position where we want, like that. Give it a second to cool and clean your tip. Take a look at your board edge on. Make sure everything is in place where you want it. Just a tad there for thermal transfer. Now I've got two corners of my board tacked. Add a little flux. And now it is just a matter of 40 solder joints. You can generally get through these pretty quick, and if you've used flux, you can get through them without even lifting your iron off the board. You can just drag it from one pin to the next. Now, while I'm soldering this, we'll talk about again what this is for. This is to make a 100 milliwatt WSPRPI transmitter to use the WSPR protocol for HF propagation testing. If you're a ham radio enthusiast, you know what I'm talking about. If you're not, propagation is the travel of the radio waves through the atmosphere. And right now we are in the bottom of solar cycle 25. The sun has cycles that last about 11 years apiece. And at the top of the solar cycles, propagation is great. You know, you can stick just about any piece of wire that's close to resonant as you want up in a tree and talk all over the world on low power. And it has to do with sunspots. Also has to do with the solar flux. It has to do with a lot of things, but that's not important. Since we're at the bottom, things are a little bit harder. And Joe Taylor, a physicist from Princeton, invented a bunch of these digital modes, and WSPR is a mode he invented. It stands for Weak Signal Propagation Reporter. And your radio just sends out a coded signal, and other stations who are running the software all over the world, if they pick up your signal, they give you a signal report, and it gets all transmitted back to a central server, and you can see how efficient your antenna is, because the antenna is the most important part of a radio station. You can have a 50,000 watt transmitter powered by 3 500 tubes, but if your antenna sucks, you'd be lucky if you transmit across town. Or you can have a 100 watt station with an awesome antenna, a half a wavelength in the air. and transmit all the way around the world. Antenna efficiency is key. WSPR lets you find out how efficient your antenna actually is. So there we go. Our WSPR board is ready. Now, these boards were kindly provided to us by our friends at PCBWay. Here's PCBWay's website. I just want to show you one cool thing here. If you go to the Instant PCBWay quote, and you go to Quick Order PCB less than 1 minute, click on that. And what you can come down here and do is start by adding a Gerber file. I'm not exactly sure where mine are. Let's see. Videos. WSPRPI. There it is. It uploads your Gerber. It puts in the size. Then you can just come down here, pick everything you want. You know, say you want a blue solder mask with a black silk screen, and you want gold covering. You know, boom, you just rock on down through there. You know, hit calculate, and you're good to go. Pretty simple. PCBWay. Okay. So, I've got our female headers plugged into the male headers onto our WSPRPI board. And now we need to solder them into the Pi 0W. So all I'm going to do is I'm going to put them in there like that. And the reason I'm doing this is if you can solder things in place, you will find out that they'll actually fit the way you expected them to. Because it has been my experience that doing all of the math in the world is no excuse for just putting things in place and making sure they're where you want them to be. I mean, this, when you solder it in place, you have basically guaranteed it's where you want it to be, because you already know it fits together because you just did it and it fits together. So anyway, we've talked about WSPRPI and what it is and all that good stuff. So I'm not going to go through setting up the WSPRPI software on the Pi for you. I will, however, provide a link to the GitHub repository where you can download it and install it. And of course, you must be a licensed amateur radio operator to do that. Mainly because, you know, well, it's illegal to operate a radio transmitter without a license, but also because you would have no way to view your reporting without having a call sign, because I will show you this in action, and what you will notice, whoops, is the way we look it up is with my call sign. I did miss one, didn't I? These gold ones are a little bit harder for me to see. But I mean, it's really simple to install. The guy who created it did a great job. All right, you don't need to watch me solder all the rest of these, do you? No, good. I'll finish up these last few pins and we'll be all done. And like one of the reasons I'm doing this is so that I can let WSPR run almost all the time and not be monopolizing my radio. There we go. Focus. Yeah, it's not bad. It ain't perfect, but it ain't bad. So I'm going to set up WSPRPI on here, and then we'll come back and we'll try it out. Okay, so we're just about ready here. There's our WSPR transmitter board. Been pretty good. Get her plugged in. Nice and snug. I got to get the SD card, micro SD card for that. And I've got this little adapter here hooked up to my vertical for 40 meters. And we got power here. So I'll get the SD card. Be right back. Okay, SD card is in. Plug in the power. LED's lit. Now this is set to output at full power on here, which is 100 milliwatts. And it's set to transmit a quarter of the time. Now the WSPR transmissions take 2 minutes. So it's going to go, out of every 10 minutes, it's going to transmit, 2 minutes basically. That's what we're going to get. So let's go over to the computer and we'll bring up the WSPR maps after this is run for a couple minutes so we get some answers, right? Okay. So we'll see if this one works. Sometimes I have trouble getting a couple of these maps to actually function properly. So I don't know why it does that. Let's see if I can log in here. See, I'm logged in, but it doesn't want to load it. This happens with Google. Okay, there we go. And there we have it. So for whoops. Let's get down here. Oh, come on, how do we zoom in? Control plus scroll. So there's me, right up there in Ohio. This has been running for about 10 minutes, so at 100 milliwatts, I'm hitting Massachusetts, Iowa, Texas, Louisiana, Tennessee, and Atlanta. I mean, it's not super terrific, and I am running a kind of a crappy lead to my main antenna. But 100 milliwatts is getting me out there pretty far. So that's pretty good. Alright. My WSPRPI 40 meter board. Yeah, I could have probably used a little bit more filtering, but it works fine. Pretty simple design. If you guys are interested in it, I'll make it available to you. Alright, well, I want to thank you guys for watching. Thank PCBWay for sponsoring this video. Don't forget to like, comment, subscribe, and share. That's it. I'm out. Peace.